Page 14 in that booklet. Just quickly run through here. Browder here, Banner here, Christine, Daniel, Lindsay, Carl, Kayla, Rovic here, Gila, Joey, Lane, Dino, Jaden, Jaswinder, Jordan, John, Anton, Lucas, Joseph, Kira, Cash. Cash, are you here? Julian, yeah. Gabriel, Richard, no Richard, Simran, Connor, Alex. Good. All right, so I'm gonna kind of sprint through this a little bit or jog through it because the key is online, right? So you should have tried this. Given a regular hexagon with a center C, so sometimes it's just the word and sometimes there's a diagram, sometimes both, right? So you gotta watch out for that. With a center C, determine the measure of the central angle of this hexagon. This should be a piece of cake here. Okay. That's 60. So you just found this one in here, right? That central angle, that's what you just found. Determine the length of side A, justify your response. That means show work. So how would you find A? Well, you know that these two sides will be the same because this is a regular hexagon, right? So 16 and 16. So I'm going to copy that one down here. This is 16, this is 16, this is side A, and this is, I just found out, is 60. Do you have to use cosine law here? Some of you are saying no, but if you use cosine law, it's fine. But there's something you should notice. If this is 16 and this is 16, right? What do we know about the angles across from them? That they're the same, right? So if this is 60, there's 120 left to be split, right? So in fact, all three of them are 60s, equilateral triangle. So that goes into classifying, right? You're gonna have to be able to classify. So that means that A therefore will be 16 whatever units, right? So this is showing my reasoning, and this is what it actually is. Can also use cosine law, right? Because you have an SAS. So if you type all of this in, you'll still get 16. You should be getting 16 or close to it, right? So 2 marks there because you had to explain how you came up with that. Determine, number 25, determine by illustration or calculation the total number of diagonals in this 6-sided polygon. I will not do illustration, I will do calculation. And I will just know that this is the formula, right? So this is 6 times 6 minus 3, which we just calculated. That's 6 times 3 divided by 2, which is 9. This page should be pretty standard. We did all of that, okay? Next. So I know I'm going a little fast, but I know tomorrow's a test, and I still want to give you a checklist, okay? And if you ever miss anything, it's always recorded. A regular hexagon, there it is again with hexagon, has side length of 10 meters. State the measure of angle A, the central angle in degrees. I just took this from old exams. They just happen to be central hexagons, right? Central angle would be 360. divided by 6, which is just 60 degrees. No big deal there. And they leave you a lot of room, so sometimes it's deceiving, like, what? All that room just to do this? Yes, that's how the provincial exams used to be. So we have that figured out. And then B says, state the measure of the given diagonal in meters. Okay. So let's go to that one. We know that they're all 10 all around. What do we know about a hexagon? We just did that. If we cut here, make a triangle, right? What do we know about the sides of these two here? What kind of triangle is formed here? It's a hexagon. So it's equilateral, right? So that means that if this is 10, this will be 10, this will be 10, all of that will be 10. Okay? So if this is 10 here, then this stretch here will also be 10. Right? So it's 10 from here to here and another 10 because you can form another triangle right here. So this whole thing, the diagonal, is equal to 20 meters in this case. And you can tell by the marks. If it's just one mark, I'm not going to expect you to use sine law, cosine law to do this if it's one mark. Okay. I will just make a note here. Hexagons. It's 6 equilateral triangles put together. If you want to add this to your study sheet, that's very unique to a hexagon. Hexagon happens to be that way, that it's 6 equilateral triangles put together. That's why bees use it. I'm just kidding. Tough crowd. Anyways. They don't want isosceles, they want equilateral. All right. Sketch a rhombus and label all congruent parts. I actually will do what the question is asking me to do. Okay, all things that are the same, label it. So rhombus is basically just a slanted square. The things that are congruent would be all 4 sides. Right? If you take your diagonals, these are congruent. So this stretch is the same as that stretch. And this stretch, 1, 2, 3, is the same as that one. Is that labeling all congruent things? What about the angles? Angles would be this one and this one. They're the same. And then you have this one is the same as that one. That is actually labeling all congruent sides. All congruent parts, I should say. You could also add that this is a 90 here, but we're not. That's not saying things that are congruent or things that are the same. So basically, for congruent sides, diagonals bisect, and two pairs of congruent angles. This should be on your study sheet, like labeled like that. If you don't have it written down, at least have a rhombus, maybe 2 variations of it. One where you focus more on the diagonals, what's inside, and one that focus more on the outside. Keep in mind that these 2 are parallel and these 2 are parallel, but that's not congruent. That's not things that are the same. Okay, so that's why I'm not labeling them here. '27. 1 mark, keep that in mind. That can't be too much work. If it's 2, 3, then it's more work. Okay. A coin is in the shape of a regular polygon with 11 sides, so they're nice enough to tell us that. That's n. State the measure of the central angle in degrees. Yikes. So it's divided by 11. What am I going to get there? Watch this. It's a decimal, so you don't deviate from the plan, right? Most of our questions so far were nice whole numbers, but you can get a decimal. So watch out for that. 2 decimals. And make sure your degree symbol is there. So 1 mark, done. And where's the central? There's a bunch here that you can label, but this is a central angle right there. You found the measure of one of them on the Canadian dollar. Is that useful for real life to know what the central angle of a loonie is? Probably not. Probably not. Okay. Determine the number of diagonals in a regular octagon. So we're just going to figure that out. It's sides times sides minus 3. Make sure you show me the work, okay? Don't just come up with a magic number. So it's 20. 20 diagonals for that one. 2 marks for that one because there's plugging in and there's also a little bit of arithmetic to get there. That's why you got 2 marks for that one. It's a little bit more than just regular. 25. Looking at the chocolate bar from the top, Brian states it looks like a rectangle. State 2 properties that make it a rectangle, right? So you can maybe just look at your study sheet and say, hey, it has 2 pairs. You have to state it, so you can't just graph it. 2 pairs of parallel sides. That's going to be my first property. It's got 4 right angles. That's good enough, right? You can say that the diagonals, 2 diagonals are congruent, right? That they go across this and they're the same length. You can say that the diagonals, what else can you say? You can have two pairs of congruent sides, right? You can say that too. And so that's basically all you need to do there. Back side. A regular polygon has central angles of 45. So they're saying that C is 45 degrees. State the number of sides that this polygon has. So central is 360 divided by the number of sides. We know this, right? So we substitute 45 into there. You put the 1 there, you know you have to cross multiply and divide. So it's 360 times 1 divided by 45. That's 8. And if I asked you to name it, it'd be an octagon, right? You never know. Oh, sorry. State the name of this polygon. It's an octagon. Next, 30. 3 marks. Given this regular polygon, and so you count 1, 2, 3, 4, 5, 6, 7, 8. That's very important. Calculate the sum of interior angles. It's 8 minus 2 times 180. So that's 6 times 180. I believe we just calculated that. That's 1080. State the measure of each interior angle. Interior angle is 8 minus 2 times 180. divided by 8, which is 1080 divided by 8, which is 135. All of these are formulas that I gave you. So I need you to take a little bit of ownership and look through that and try to make sense of it if you're still not sure. Notice that a common mistake is that students get 8 minus 2 is 6, and then they'll put a 6 down here as well. And that is not right. This is 8, right? The number of sides. So you're basically splitting the sum of all interior angles amongst the 8 interior angles you have. The maple leaf here, there's 11 equilateral triangles, right? So state the measure of angle A. So if all sides are the same, then angle A is going to be 60 degrees, right? Equilateral. So that's your reasoning there. B, state the measure of angle B. So watch out here. I'm going to go a little up and show you how I got that. If this is 60, then this is 60 also here. Okay? So they're along a straight line. So they're supplementary. So angle B is 180 because that's the whole line minus 60. So it's 120 degrees. And I will just say it's a straight angle is equal to 180. So let's do this. Right? We have our triangle there. This was 60. So this is 120, which is angle B. Right? State the type of quadrilateral created by combining triangles X and Y. I need your input on this one. What type of quadrilateral, if you combine, talked about this at one point. What would it be? Yeah, Joey. A rhombus? Would we have an agreement on the rhombus? Rhombus wins. What about a kite? Not a kite? It would not be a kite because a kite would be two isosceles, right? Where these two are the same, these two are the same. But if you have two equilaterals, it's a rhombus. By the way, you wouldn't be completely wrong in saying it's a kite. But I don't know if you remember, I asked you to highlight, be as specific as possible. So narrowing it down, it's a rhombus, right? As specific as possible, it's a rhombus. Consider the regular decagon. You can either count. I will not always give you a diagram. So the number of sides is 10. The prefixes are, I think, on page 203 or somewhere. All the prefixes are there and the number of sides that go with it. State the sum of interior angles. 10 minus 2 times 180. So it's 8 times 180. That's 1440. The more angles, the more interior angles there are, the bigger that number is going to get. If it's 37 sides, it's going to be a lot bigger. 3,000, 4,000, and so forth. It gets bigger. State the measure of the interior angle. I think you get the point, right? Like there's some in interior seem to go hand in hand. So I will just go 10 minus 2 times 180 over 10. I will steal from the top because this is the same as the sum. So you take the sum and you split it in 10. So it's 144. degrees. I think there's one last section there. Oh, that's it? Okay. What are we time-wise? Okay, I will give you a checklist. You want it at the back of this? That's where I'm going to put it. Or let's do booklet maybe. Maybe booklet is a better spot for it because that one is less likely to be lost. So go to the back of the booklet, chapter 5, just go to the back. I will give you a test checklist there. Chapter 5, geometry, test, checklist. Okay, you're supposed to know your Pythagorean theorem, obviously. Classify triangles by angle and side. Okay. Quadrilaterals, properties, right? You have your rectangle, parallelogram, square, rhombus, kite, and trapezoid. Right? You should have a section on your study sheet where you have at least the diagrams, if not written properties. Like, it's up to you. But remember to build. Don't use up half a page or more, right? Like, you want to build your study sheet. Find height and area of trapezoids. Right? You have the right and isosceles. And determine sides and angles in a quad. Okay. Sketch and label quads. Polygons. And I'll do this. Polys backwards. Find number of sides. Calculate perimeter of poly. Review buying used vehicle. Maybe I will just say review cosine law. specifically, right? So SAS as well as SSS, right? So just know, because sometimes we need them to figure stuff out about triangles, and you got to be able to do that. Oh, remember there are 2 test reviews that I gave. The key is out. I'm trying to see if in the booklet if there's still more. If you want more, then you can go and get it there. This is all on the video. Oh yeah, there's a chapter test, a mock chapter test in here, pages 10 to 13, I believe. 10 to 13. Chapter test, page 10 to 13 in the booklet. Key will follow. I have the key. I can post it